Hi, everybody. My name is Joe Kelly. I am the Community Relations Program Assistant at the Rochester Hills Public Library, and I'd like to welcome you all to this evening's presentation, NASA Space Exploration and Discovery with Jerry Chevrier, local NASA Solar System Ambassador and member of the Oakland Astronomy Club. We'd like to thank the Friends of the Rochester Hills Public Library for supporting our programs through their many fundraising efforts, and we greatly appreciate their support. You can register for our upcoming programs by visiting calendar.rhpl.org this Saturday. The librarian is hosting an author talk on Zoom at 2 p.m. with local writer Esperanza Sichuan, who will read selections from her book, Shades Detroit Love Stories, and participate in a Q&A with Rochester writer founder Michael Dwyer. This evening, all attendees will remain muted throughout the program. Please ask any questions you have in the chat feature down below. Once we come up to a Q&A segment, we will go ahead and take the time to answer those questions. This program will be recorded and available to view on the library's YouTube channel about a week from tonight. For the presentation tonight, we have to thank the NASA Solar System Ambassadors Program, which works with volunteers across the nation to communicate the science and excitement of NASA's space exploration missions and discoveries. Jerry has been a NASA Solar System Ambassador for 7 years. The Oakland Astronomy Club has been a part of the Rochester community for 35 years, and it's a nonprofit organization of amateur astronomers who promote the enjoyment of astronomy through educational outreach at local community events, nature centers, and through monthly viewing at the Addison Oaks County Park Telescope platform. Tonight, Jerry will share with us NASA's space exploration missions and discoveries. So please, everyone, welcome Jerry Chevrier.
Hello, everybody. Yeah, got a couple of videos. That's kind of cool. I want to thank the Rochester Hills Public Library for hosting this. And as you indicated, I'm a NASA Solar System Ambassador for this area. They have ambassadors all around the United States. And what we do is we reach out to the public to get interest in astronomy. And so I do libraries, I do Rotary clubs, I do schools, I do college, elementary, grade school. So if anybody's interested in having someone come and talk about astronomy, you can let me know at the end of the event. So the topics tonight were top astronomy events. It's hard to pick them because there's so many of them, but we're going to talk a little bit about a picture of the first black hole taken with radio telescopes. I find that very fascinating. The astronomers at the ISS, the International Space Station, just recently set some records. We'll talk a little bit about that. A big one for me is telescopes, because astronomy uses a lot of telescopes. And if anybody's familiar with the Hubble Telescope, that's the telescopes that's in space today. It's going to be replaced. So it's a very, very, very big event for astronomy and for the world, actually. And then we're going to talk a little bit about gravitational waves, and I'll keep this. I love talking to people in person because people can ask questions as we go, but we're going to hold them to the end. So I have several telescopes. I have one in Oxford, Michigan. That's a dome. There's me sitting there. And so people ask me, what do I look at? So on the top there is a star cluster on the left-hand top. Those are clusters of stars that are located in the universe, and in this particular one, there's over 500,000 stars. And so I'm not sure why all these stars are in one location, but they're really cool to look at. The next one is a galaxy. That's Andromeda, which is the closest galaxy to us. It's a very large galaxy. It's a spiral galaxy like ourselves. The next one are probably the coolest things to look at, and they're called nebulas. And there's different types of nebulas. And what a nebula is, pretty much everything starts with a star. Either it goes, and when it goes supernova, which means it blows up, it can become a nebula like this. So that's the gas left after the star exploded. So they're called nebulas, and they're really fascinating to look at. Of course, we all look at planets, and then lately we had a comet and asteroids coming in, but mostly comets I look at. Again, as mentioned, if you guys are in Oakland County, Oakland Astronomy Club is a great club. They have a very large telescope, a 17-inch Dob in Addison Oaks, and they hold observing site parties for people. So if you are interested, you can just Google Oakland Astronomy Club, and they put on local programs like this for schools and parks and star parties. We didn't have a lot of star parties this year because of the virus, but that'll change. So again, if you're interested in seeing a large telescope and looking at planets and nebulas, contact the Oakland Astronomy Club, and they'll let you know when they're going to be out in Addison Oaks. So this is the largest cluster in our galaxy, and the problem is it's in the southern hemisphere, and it's got 10 million stars. So I'm just going to show you a couple of my favorite objects to look at. This is my favorite galaxy, called Sombrero Galaxy. If you look at it, it kind of looks like a hat from Mexico, maybe. And it's a very beautiful galaxy. I love that one. This is my favorite nebula. It's called the Crab Nebula, and it's actually visible right now. Actually took a picture of it last week. And then Saturn and Jupiter are out right now. If you go outside and look, let me think about this. Look in the south. Look south and look up in the sky, and the brightest thing you see there is Jupiter, and right to the left of it is Saturn. So, and then Mars is also out today. So right now is a great time to be observing planets. So usually when I have a bunch of people, I ask people what this is, and it's too bad that I can't look at the audience because most people don't know what it is. And what it is, and if you do, that's pretty good. This is called Sputnik. This was the first satellite put into space by the Russians in 1957. And that little satellite, all it did was go around the Earth and go beep, beep, and it caused quite a commotion. It actually changed the arms race, actually. But Sputnik changed a lot of things. What happened is the NASA organization got created right away. And I usually look in the audience and say, who knows what NASA stands for? And maybe one person would know, but it's called the National Aeronautical Space Agency. And what it does is does things with space and weather and all kinds of things with astronomy. Here are a couple things that it's done. And again, when that Sputnik satellite went up in 1958, Eisenhower signed and started the National Aeronautical Space Agency. And to the left there is the International Space Station. And they set a record this year, and I'll talk about it. On the bottom is probably, maybe a lot of you weren't even around, but this is the event that got me interested in astronomy. It's the footprint on the moon. And what's exciting now is that we are going to go back to the moon and then to Mars. And what's really cool, if you Google any of this stuff, say mission to Mars, they're going to be building an international space station like that going around the moon. So when we blast off from the moon and we want to go to Mars, we can go to the moon first and gas up and go back out into space. So it's going to be kind of like a landing site, a landing system. In the middle was a shuttle that was around for quite a while, putting people into space in satellites and people going to International Space Station. And on the bottom right there is the new capsule that just went to the International Space Station, and we'll talk about that. So one of the things that is really cool about NASA is that you can work for them. They're all over the United States. There's 90,000 people working for them today. And I always look out in the crowd and look for some kids and say, who wants to be an astronaut? And if I was a kid, that would be something that would be attainable, because we're going to need a lot more astronauts than we ever have in the past. So what's it take? You need to be a U.S. citizen. You need to stay in the STEM, science, right? Technology, engineering, and math. You need to stay in that lane at school. Some people don't like that, but the people that stay in that lane or take those types of courses would be set up to either be an astronaut or work for NASA. And then you got to pass a physical and other things. You got to be 2 years related experience. But the basic thing is to stay in STEM. And for all the women out there, women are NASA is very interested, I could say, in women working for NASA. So if you're a girl and you interested in being an astronaut, stay in STEM, and you'd have a good shot at becoming an astronaut. And I think that's pretty fascinating because of the plans that we have going to Mars and beyond. We're certainly going to need them. So I'm going to talk a little bit about speed. Everybody likes speed. So up on the left-hand side, there's a dragster. It goes like 320 miles per hour, and that's pretty fast. You think of a car going 320 miles an hour. That's really fast. And then we had a spy airplane, and that was that one there in the black. It went about 2,275 miles per hour, which is pretty fast. Then rockets go around 10,000, and the fastest thing so far has been Apollo 10. When it was in space, it went 24,000 miles per hour. So everything's pretty fast, but I want to put everything in perspective about the size of the universe and the distance from things. I found it very fascinating. So I want to talk a little bit about the speed of light. So anybody?
Jerry?
Yeah.
Real quick, would you mind at the bottom right hand of your screen, like just to the left of like the zoom bar, like hitting that little like slideshow, like.
How's that?
Yeah, that looks great. Awesome.
All right. Sorry.
No worries.
Yeah. So I know I'm going to age myself a little bit, but when I was in college, I used to watch Star Trek all the time, and I would manage all my classes so I could watch Star Trek. And when I was watching it, I thought they were jumping from universe, to universe to universe to universe. And I'm going to show you in a little bit. I don't think they ever got out of our universe because of the size of our galaxy. So anyways, take a look at that and pretend like you had one of those, and you could go to speed of light, okay? Think that in your head. And so if you got into that spaceship, and this is usually where I hold up my spaceship and kind of turn the lights on in a room, but if you say one, say 1001, in 1 second at the speed of light, you go around the Earth 7 times. And it's 186,000 miles per second. So that's real fast. And there's a lot of things that go along with the speed of light that get discussed. If you go to speed of light, they talk about time and time standing still, but we're not going to talk about that tonight. We're just going to talk about if you had a spaceship like this and it could go to speed of light. So actually, I want to just think if you were on the Earth here, and these are all the planets, and you want to go to Pluto, okay? And you had that spaceship and you said, hit it, and you went the speed of light, you'd be there about 8 hours to Pluto, okay? And then if you wanted to go to the next sun, and the sun is a star, just like our sun is a star, it would be, everybody hang on, 4 light years. Let that sink in for a minute. Light years. So you have to go to the speed of light, 186,000 miles per second, for 4 years. That's how far away the next sun is. I just found that pretty fascinating because, us looking for alien life, if we find it, it's pretty far away. This is our galaxy, the Whirlpool Galaxy, okay? So if you were on one end of the galaxy and you wanted to go to the other end of the galaxy, and you had remember we had that spaceship, right? It would take you at the speed of light 100,000 years. I'll let that sink in for a minute. 100,000 years to get from one end to the other end of our galaxy, the Milky Way. And I know there's a lot of words in here, but you can see the sun. Our sun is on the bottom middle. If you look close enough, you'll see sun. So on the top is a picture of our galaxy from the Earth. And someone went around and took that picture and put it together. You don't see that very much in Rochester or Lake Orion or Oxford because of light pollution. But if you ever get to a desert, because deserts are dry and cold at night, and there's no moon. If you get out of your car and look up, you'll see the Milky Way galaxy, and you'll be astonished. I guarantee it. So I wanted to give you an idea how big our galaxy is, the Milky Way galaxy. Now, the next galaxy, the Milky Way, is on the left-hand side, and there's our beautiful spaceship that's going at the speed of light. And I want to go to Andromeda, which is on the top right-hand corner, and that's the closest galaxy, spiral galaxy like us, okay? How it goes around and around and around like that, that's a spiral galaxy. And we need to go to Andromeda. And you had your spaceship, remember it goes speed of light, 1 second, 7 times around the world. You'll get there in 2.5 million. That's right, million. 2.5 million light years is how long it takes to get to the next galaxy like ours. So if we're to find life in this galaxy, the Andromeda galaxy, it would be a long time before they could get there or we get there. And there's a lot of talk about bending of space and wormholes, but I'm just talking about the ability for a spacecraft to go at the speed of light, which there is no spacecraft that can go to speed of light right now. So, and again, it's just the distance. I kind of want to get you an idea how big things are. And then this is the latest thing from NASA, is how large is the whole universe? All galaxies, the millions and millions of galaxies that are out there. And the latest thing is that it's 93 billion, that's with a B, light years. So you can see that the universe itself, it's very, very large, and we're such a small part of it, of being in that universe. So when I first started in astronomy, one of the things that really kind of blew me away was this graph. So if you take all the planets, all the galaxies, all the suns, all the nebulas, all the star clusters, everything that you see, visually you can see, it would make up 4% of the universe. And that kind of floored me because I thought it would be a lot more. What's left is dark matter and dark energy, and that's, you know, over 95, 96% of the universe. And we know very, very, I'll say very one more time, little about dark matter and dark energy. So it's kind of interesting that for all the things we know, we don't know very much about the universe. And so there's a lot of activity going into understanding dark matter and dark energy right now. And we could talk about that all night, but that's not the purpose today. But lots of money, lots of activity going into figuring out what dark matter and dark energy is. I want to talk a little bit about telescopes because it's going to, we've got a new telescope going to be launched. And I believe it's going to change astronomy forever and really do a leap forward in our understanding of the universe. So on the top left is what they call the Hubble Telescope. It's actually, I'm going to talk a little bit about that. And it's going to be replaced with the one on the right. And I'll be talking about that. But there are different types of telescopes. Telescopes that go into the sky, into the outside our orbit of the Earth. And then there's stuff on the Earth. And these two on the bottom on the left-hand side are in Hawaii. They're called Keck 1 and Keck 2. And this is usually the part of my presentation. I give somebody a ruler, a tape measure, and I say, go out 30 feet. So that person would walk 30 feet away. And then I would say that's the size of a mirror in those domes. So the largest telescopes today are about 30 feet mirror-wise. The dome itself is huge, but the mirror on the telescope that collects the light in the sky is 30 feet, which is pretty big. This one in the middle is in the Canary Islands. And what they've done is they put two telescopes together like binoculars and increase the ability to collect light. So that's in the Canary Islands. And then Boeing has a plane that they fly up in the sky and they open the side of it and they hang a telescope out of it. So lots of different ways to view space from the ground with these large telescopes. So this year, 30 is the 30th year anniversary of the Hubble Telescope. And the Hubble Telescope is the one that's in space. And there's a beautiful picture of it, about 300 miles above the Earth. It points out into the universe and takes stunning pictures. And if you bear with me, I'm going to show you a couple of those pictures. There's a close-up of it. And just before we get into the pictures, when this thing launched, it didn't work. And so these are articles that made fun of the Hubble Telescope. And they had to go up in the space shuttle and fix the lenses on the Hubble. And I just found that fascinating. This was a picture. So what they did is they opened up the Hubble Telescope and they left it open for hours and collected as much light as they could. And this is the deepest image they've taken with the Hubble. And all those dots are galaxies. So you can imagine how far out they went. I found that pretty fascinating. So Hubble's been up there for 30 years. It's worked beyond. It was up there for 10. They thought there would be 10. It's been up there for 30. A well-crafted telescope. So I put Spider-Man on here because the next telescope, I kind of want you to remember it. If it's supposed to launch this year, it got moved into next year. I'm hoping that it does launch next year. And so when you think of Spider-Man, he shoots out webs, right, to swing from place to place. And this new telescope is called the Webb telescope. So hopefully that reminds you when it gets launched next year. Believe me, it will be in the papers. It'll be on TV. You'll hear about it. And it's supposed to be launched next year. And it's named after one of the administrators at NASA during the Apollo programs. And it's a fascinating telescope. Here's another picture of it. So remember I talked about the Hubble, and that was the telescope that's in space. It's only 340 miles away from the Earth. So it's in what we call the Earth's orbit, right? So it's going around the Earth. The Webb's going to be 1 million miles out. And what that means is that when this thing launches, they won't be able to fix it. So if it goes out, that bottom thing, it costs $10 billion to build this. When this thing goes out, and if it opens up in space and doesn't work, we lost $10 billion. So that's the reason there's so much. It got delayed a little bit, one, because of the virus, but two is because everything's got to be redundant on this thing. So when something goes wrong, they got a backup system because they won't be able to fix it. So the mirror of a telescope is the most important part of a telescope because that's the amount of light you can catch. The bigger the mirror, the more light you can catch, if that makes sense. So the Hubble is 8 feet. Its mirror is 8 feet. You can see the Webb telescope, it's going to be 21 feet and 4 inches. So it's going to be 3 times as big, and it's going to capture things we've never seen. So remember next year when this thing launches, you remember me, Jerry, the NASA Solar System Ambassador, told you about it. This is a picture of it being built. And actually, I think this is being tested right now. And what's really nice, really kind of cool about it is that it's gold plated because of the cold it's going to be operating in to take these images that they needed to coat it with gold. So I'm going to play a little video here. I think you'll enjoy it. Oh, sorry. Start it again.
James Webb Space Telescope is the next premier space observatory.
You might have to hit the share.
I'm sorry, what? Let me pause it.
You might have to hit the share screen button.
Oh, got it.
Yeah, just to bring up a new window of the video.
Oh, so I brought this up. I hit the wrong button. Oh, you mean share down here?
Yeah, in Zoom. Yeah, you might have to hit share screen just to share. I think you're showing like your slideshow right now. I think you have to switch to whatever window the YouTube video is open in.
Oh, I don't know which one. Do you know which one it is? Is it?
It should show a preview. If you have like an internet browser open for it, it should be whatever that browser is.
Okay, I'm not sure how to. I usually do this in person, so
Okay.
Maybe we're gonna skip it, eh?
Let's. What happens when you hit the share screen button on Zoom?
Where is the screen? Up here, right?
Yeah, it's in the. It should be like towards the bottom. It's like a green button with the arrow. It's the one.
Oh yeah, okay, I got it. Let me click it. All right.
Yeah. Does it give you any options?
Let's take a look. It comes down here. Share options. Start video.
Yeah. I think so.
Oh, that's video of me.
Oh.
Yeah, that's not it.
Shares.
Sorry, everybody. Share.
Yeah, there's a button that says share screen. It's like a green.
Oh, and then it comes up and it
Yeah.
gives me my thing, and so I would pick. Well, it's Google. It's YouTube. And
Yeah.
Okay, let's see if YouTube's on there. No.
It's a YouTube.
Copy. Embedded. It's not Facebook. It's not Twitter. It's not any of these.
And the YouTube video is open on your browser?
No.
Oh, open it up on your browser first, then do the screen.
Oh, okay. Okay, why don't I just go to this with my, okay, hang on. Copy that, let me get out of this. I hope I'm not gonna screw everything up. I don't know how to get out of here. That's my problem.
Well, if you click the link like you did before, like it was playing,
right?
Try sharing your screen now that it's the video is playing and open.
Okay, hang on.
It will extend the discoveries of the Hubble Space Telescope.
Oh, you know what? I got two of them going now. Oh, man. I'm going to stop this.
Okay.
It is named after James Webb, NASA's second.
It's too bad because it's really good.
Let me.
All right. All right, now I'm back to Zoom, but now I've lost my presentation. Oh my God.
If you can, I think you should be able to minimize Zoom.
Okay. Oh, and go back to here. Okay.
Yeah.
Escape. All right.
There
Are we back? Are we back?
On the presentation.
Back to the presentation?
Yes.
All right. Well, guys, Google it. I guess. You'll enjoy it.
if I could see the link there, I might be able to get it working.
You want me to show you? You want me to show you the link?
Yeah, just hop back to the link.
Okay,
there.
I will. Right there.
Okay. Okay.
So I can go on, and then you can, if you can get it,
Yeah.
hop in. Okay. So I'm going to keep talking about telescopes. So again, Hubble is what's in the sky now. The Webb, think of Spider-Man. You're going to remember the Webb telescope when it gets launched next year. So the largest telescope, I told you the lens are 30 feet, which is pretty long. If you go outside one day and have a big ruler and go out 30 feet, you're going to see it's pretty big. This guy is going to be bigger. This is the largest. It's 39 meters. It's almost like 90 feet. This is being built. It's called European Southern Observatory, extremely large telescope. And it's being built right now in Chile. And Chile has a location near in the mountains that is very, very good for astronomy because it's in the desert, again, dry atmosphere, cold at night, and this is being built there. And so this would be the largest telescope in the world. It's going to take 10 years to finish, but it's being built right now. And we're also building a real large one in Hawaii. So if you're ever interested in telescopes. This fascinates me here because those other telescopes are visual telescopes. They're looking at the wavelength of what we look at with our eyes. These are radio telescopes. And again, I talked about Chile because of its mountainous regions that are in the desert. This is called what I'm just going to call it ALMA. And what you got here are 66 radio telescopes. And they're moved around. See the little truck there moving them? So they use all of this together to take images of the sky. And they can break it up and 10 over here, 11 over there. But this is really giving us some very deep images. And so if you're ever interested in looking at some really deep images, just Google ALMA in Chile and you'll be fascinated about what they're trying to do there. And the reason I bring this up is because we just took the first picture of a black hole and we used radio telescopes like this to take the picture. And so the whole program is called Event Horizon. And so we used radio telescopes in Spain, Arizona, Mexico, Hawaii, Chile, and then on the Antarctic. And they all coordinated looking into space. So if you think about it, this telescope is as big as the Earth. I mean, it's got it spread all around the Earth. And they took a picture of the first black hole. And I'll show you a picture of it. But this is a pretty big effort on the part of astronomy in general. They had like 300 people working on this, 20 different countries, and it just got announced. Here's the picture. I know that doesn't, people might look at that and say, okay, it's light. That's a black hole. And the reason black holes are difficult to photograph is because they're black. Pretty simple, isn't it? They're black. And so what happens is there's plasma getting into the black hole, and sometimes the black hole shoots out plasma. And so what we're seeing here is material coming out of the black hole, and then we're able to photograph or image that and then see where the black hole is. And that particular black hole is, if you take 100 suns, our sun's pretty big, put 100 suns in one little black hole there. So these are pretty big black holes. And this is the first photograph of it. The other thing that happened this year is that we, as a nation, when we went to the International Space Station, we had to pay the Russians to take us for years. Because when the shuttle stopped flying that NASA had, they had no replacement. They were underfunded and they couldn't get it done. And so they let out 2 contracts, one to SpaceX, which is a private, that makes sense, private company. NASA is run by the government. So they put out a contract to SpaceX, gave them $2.6 billion in 2014 to come up with this capsule. They call it the Dragon. It's on the left-hand side. And to fly 6 missions to the International Space Station. Then they went over to Boeing and gave them $4.2 billion in 2014, same time, and told them to build one too. So the one that won, they're both going to be used, but the one that got there fastest was SpaceX. And that happened this year. So it was the first time this year, and I don't know if any of you watched it, but that SpaceX Dragon capsule brought American astronauts to the International Space Agency and docked for the first time in years. So it was a historic event, and I hate to say this, but I have another video coming up of it, but maybe we won't be able to see it. But you can Google it. If you Google, go back and Google SpaceX Dragon docking with International Space Station, and they'll show you it if you missed it. I didn't miss it. So I just wanted to show you the size of the International Space Station. That's up top there. So you've got multiple nations working together in space, and those, of course, solar panels to keep everything, energy-wise, and they have been adding to this as it goes around the Earth. And again, we're going to build something like this by the moon, and there's a whole program. That's a whole new presentation, but that will be a station like that by the moon. So in May of this year, 2020, that's the Dragon, or SpaceX capsule called the Dragon, hooking up to the International Space Station. That's a picture of it. And then a great video. Hi, come on. Are you able to do that video on YouTube? Oh, he must be working on it. So the other, I told you that NASA, if you're a female, and males are being hired too, but it seems that they've got to focus on women working for NASA. So you got a really good chance if you're STEM, again, STEM, science, technology, and engineering, and math. You got to stay in those subjects. I know they're the hard ones, but if you can stay in them, this lady here, Christina, set the world record on being on that space station for 328 days. That's a long time in space. But that's a picture of her on the right there. So that was a record just set in this year in 2020 in February. So again, we're going to need more astronauts. We're going to need more people going into space. And if you think about the new agency, space agency that the government had set up, they're going to need astronauts too. So a cool field. When you get into college and you graduate, take a look at NASA before you go work for somebody else. I'm plugging NASA, of course.
I was unable to get the first link to work.
Yeah.
I think it was like a mix up with like the L's, like a couple of letters. I couldn't tell if they were L's or I's.
Well, you can just Google YouTube and say, you got one?
I do have one for the Dragon and ISS.
Okay, let's play it.
Sure.
I think it's worth it.
Let's see if I can do that. Okay.
That crew hands-off point should come up in about 3 minutes or so, right before we get that final dock. It comes about 20 seconds prior. We're just about 2 meters away from the station still, and that's just the crew not issuing any abort commands. At that point, it would be too late, and so any aborts would be executed automatically by Dragon itself.
Is it coming through?
Yeah, I see it.
Right.
Hey, whoever's listening, isn't the imaging of this phenomenal?
Per second.
I mean, look at that.
See the service section.
It's 300 and some miles in space, up in space on the International Space Station. And I thought the photographing was just, the video was phenomenal. That arm there is part of the International Space Station, and they're docking into the station right now. This is a big deal because, again, we're in charge of bringing our own astronauts to the International Space Station. We don't have to pay Russia to do this anymore. God, I just can't believe the great video of this.
There's 4 black circles are the 4 bulkhead Dracos, not to be used at this time. And of course, the pedals of the soft capture system. Wow. Dragon on the big loop or inside the picture. Not make out the dark concept of the outline. Okay, we're less than 10 meters away. Again, we're closing at that rate of less than 1/10 of a meter per second. Should be just about 1 minute 45 seconds away from docking. It's a centerline camera right in that middle, so that you can see where the forward hatch is. And right in the middle of that, there's a window. There's a centerline camera that is aligned with the center of the vehicle and the center of the docking mechanism. So that is what the autonomous docking system is using to line up with sort of a crosshatch, cross target on the docking port. Again, the forward docking port on PMA2, or the pressurized native adapter. We're just 5 meters away. Again, we're racing that sunset. Dragon continues to close, 4 meters to go. The shadows of the space station on the vehicle. Yeah, you can actually see the centerline camera pretty clearly there, sort of with the contrast of the sun right now. 3 meters to go.
So once that docks up, they come through that hatch and they come into the International Space Station. So there's astronauts in there.
We are inside the hands-off point, the chop crew hands-off point, 1 meter to go. Soft capture complete.
Soft capture confirmed. Stand by for retraction and docking.
And we just heard it, soft capture. We have docking, that coming at 7:16 a.m. Pacific time, with the station and Dragon flying 262 statute miles right over the border between northern China and Mongolia. So a little bit of motion there of Dragon. There's that relative motion with the soft capture system that's damping out. Once that motion is clear, then the soft capture system will be retracted, and Dragon will go for hard capture. Again, if just now tuning in, that soft capture, that docking coming 7:16 a.m. Pacific, 10:16 a.m. over on the East Coast. Dragon and International Space Station. We're flying 262 statute miles right over the border between northern China and Mongolia.
Cool.
So that soft capture ring now going to retract. It's one more step on the way to docking complete.
Were we wanting to end with the video, or?
Yeah, that's good. I just kind of wanted, this is a big moment for NASA, number one, and for the world, for the United States, because again, relying on another country for our space, it puts us at jeopardy, I think. And anyway, this stopped it. And
you can reshare your screen whenever.
okay, share screen.
Yeah, the share screen button and then your slideshow.
Got it. All right. So again, that was I keep saying it's a big moment, but for me, I was amazed that nothing went wrong, because a million things can go wrong with that kind of thing. So the next topic is what's happening in 2020 is I call it the invasion of Mars. We have 3 different countries going to Mars this year. I mean, they're gonna have to put a stoplight up there for the traffic. NASA's got one, and I'll show you that. China, again, last year, sent a rocket to the far side of the moon and landed, not with people, with a rover kind of situation. And then European Space Agency is sending it, and for the first time, the United Arab Emirates are going. I've been in astronomy a long time, and I didn't know that their space, I should maybe know it, but I didn't know their space program was that good. I knew China's was, and I knew Europe, because a lot of times we do joint things with the European Space Agency. So this is a picture of Mars. Mars is going to be probably the best time to take a picture of Mars will be this month and next. And Mars, if you look at the top of it, it has ice craters and fascinating planet. And again, for all you kids out there, you could be the astronaut landing on this planet if you, work for NASA and go. I just find it fascinating. All right, so now I can't go. Okay. Oh, there I go. Sorry. So this is a picture of what we're sending up. Is our rover on the left-hand side. It's a brand new rover going up. It's got drills and cameras, and it's going to be, it can travel longer. It can do more experiments. It can do a lot more things than the current rover. But what I found really cool is the helicopter that's going to be there. So this is the first time they're going to have a detachable helicopter drone on Mars. And if you want to find anything really cool, and maybe you don't think this is cool, but Google that, the NASA Mars helicopter drone. It'll show you video of it flying, and so this is a pretty exciting time. But again, a lot of people going to Mars. I think that there's no question in my mind we'll be going to Mars. We'll go to the moon first again, and then we'll be heading to Mars. And President Trump has funded all of that. So what's happening in the skies? Well, I'm going to skip this for a minute. How much time? Still got time. I want to talk about gravitational waves. And this might be, I'd like to talk because I find it fascinating. And maybe you won't, but I do. So this is a picture of the Earth. And when you have an object in space, think of it as a heavy object bending space. So see the little cup there? So objects bend space, and that's where gravity comes from, is the bent space pushing in on the planet. And if you take a look at the sun has a bigger dip in space, and the planets sit in the dip and rotate. That's why they don't fly away, because the gravity from the hole that the sun made in the fabric of space keeps our planets there. I'm not going to go any more depth than that, but so there are ripples in space. So when a sun, again, everything starts with a sun. There are different sized suns. Our sun is a medium sun. There are suns that are 1,000 times bigger than ours. When those supergiants explode or go supernova, they crash in on themselves because their gravity pulls all the material in and becomes so heavy it bends and produces a hole in the fabric of space, and that's how black holes are created. So those are huge, huge items in space. Every galaxy has a black holes, and usually in the center is the biggest. So what happens when two black holes collide? Because they do. That is a tremendous, I'll say tremendous twice, amount of energy that gets released and causes the fabric of space to have ripples in it. Okay, so think two black holes collide. They disrupt the whole fabric, and it's like throwing a pebble out into the lake, and it causes ripples. It sends ripples to the whole universe. And then the other thing that sends ripples are neutron stars. I'm not going to talk a lot about them, but they are the most dense stars anywhere. And when they collide, they have a violent force as much as two black holes colliding. So two things make these ripples go through space: neutron stars and black holes. And we have facilities that look for the ripple, and they're called LEGO. And we'll call it the Laser Interferometer Gravitational Wave Observatory. And we have two of them in the United States. And they go out with these tunnels that are going out. They have a laser going through those tunnels. And when the space fabric ripple comes to the Earth, it goes right through us, these are able to detect the ripple. Okay? So if you want to, well, one, be a great place to visit. I haven't visited one of these yet. But it's a great thing to Google LEGO and just look at the delicate lasers that are going out in these things 2.5 miles out. So they detect ripples in space, and there's a bunch of them around the world. We have two of them. If you take a look in the United States, one in Hanford, one in Livingston, and then those are operational. There's one in the European nation, and there's the green are under construction, and then there's one in India that's going to be planned. So a lot of money is going into understanding these gravitational waves, and I'll tell you why. It's because the universe, I just say 95% of it is dark energy and dark matter, and they don't know what it is, and this is going to help them understand it. So a lot of money is going into these gravitational wave observatories. That's it. So I'll take questions now. I can talk all day, but I think that's enough. Anybody have any questions?
Let me just leave a message here so that people can know where to leave questions.
Okay, and then to everybody, if there's a group, Boy Scouts, Girl Scouts, schools that are interested in having a conversation on astronomy, let me know.
I know we got one just a little bit earlier in the presentation, but somebody was asking, they've just repeated it, but they said if, our Earth-Moon system and the fact of the moon orbiting the Earth, maintaining the stability of Earth's axis is so crucial to life on Earth, why focus on Mars, which has no axial stabilizing moon? So basically the idea that Mars is already a pretty hostile environment, and it's potentially even more so without like a moon that can allow life the way on Earth. Why would we be more focused on a planet like Mars?
That's a good question. So I'm going to explain why Mars is hostile place to live, because it is. The radiation there, the dust storms, it has very little atmosphere. It would be a very, very tough place to live. But you can build places there to do that. So the reason that it's so hostile is because the sun puts out solar winds. They go 1 million miles an hour. So think of something going particles, plasma, particles going through from the sun at 1 million miles an hour. So the only reason we exist here on Earth is because we have a magnetic field that comes out of our planet. And it deflects those solar winds. That's another fascinating Google, YouTube event. If you want to say gravitational waves, not the gravitational wave, but the magnetic field of Earth, take a look at that. Anyway, these winds are coming and it deflects them away from the Earth. What happened to Mars is it lost the strength, its magnetic field lost its strength, and it's then stripped away the atmosphere. So that's one of the reasons that place is so hostile, is because the atmosphere is very, very thin. Radiation, I mean, if you go outside and you don't have the right protection, there are going to be problems. Let's just say that. So why are we going to Mars? I get asked that a lot. So first place we're going is back to the moon. So the moon is critical. Tidal waves, the balance of the Earth, we got to have that moon. And you're right, there's no moon in Mars, so why go there? If you really want my explanation, I don't know, maybe this is not NASA, you'd have to ask them. But here's what I think. I think when we went to the moon the first time, the technology that came out of that was fascinating. We learned a lot of new equipment got built, and we microwave, for an example. There was no microwaves for Apollo. That came from them. There's a lot of material and inventions that come from pushing limits on technology. So you agree the moon's important. So we are going to the moon. So I hopefully you agree with that one. And we're going to build that station out there, and we're going to be on the moon. Mars is really the only other next step we have. So I believe that there's a little bit of positioning in space. I mean, whoever runs space will control a lot of things. And that's why we have the USA has a new space agency that they just spun up. And it's going to all be about satellites. It's going to be about just a lot of activity in space. And whoever controls the moon and Mars is going to control a lot of stuff. Let's just say that. I'm not going to get political on you, but and that I believe it's one is for the adventure of it all because it's there. It's the only other place we can go besides the moon, and have a fighting chance. You go to Mercury or Venus, way too hot, very extreme. So Mars is it. I don't know if I answered your question, but that's my long-winded answer.
I think that kind of got to some of the ideas of at least why I would be going there.
Right.
While I pick out the next question, would you mind maybe going to like one of the slide pages or even the intro, just to look at something?
Yeah, got it.
I think
that's two neutron stars. Cause a gravitational wave.
The next one, somebody asks, you mentioned that the NASA had disbanded the shuttle program, and they were curious, were there any reasons beyond like a lack of funding? And maybe even just like what contributed to a lack of funding? Like, was there a lack of interest or?
Well, I believe that it was a lack of funding, just simply that. Whoever was funding NASA at the time, it didn't give them the money to do it. Maybe they weren't thinking about what happens when that space shuttle went down. I mean, wasn't working anymore. What are they going to do? Mm-hmm. So it needed a strong voice in government to fund these things because, look at the Webb Telescope. That's what, $10 billion? That's a lot of money, right? So you need people high in government to say this is important to us. And I think you see that today with this president, that he's doing a space organization. He's funded NASA. And one of the things that I find is that NASA runs so much better now with private industry doing its work, a lot of its work. Like, we are building another rocket. I got to say that, but SpaceX and Boeing are more efficient. Let me give you an example. And I love NASA, but when they shoot up a rocket, they just shoot it up and it falls in the ocean. That's it. Well, SpaceX said, hey, when you shoot up a rocket, we had that rocket that went up, we had to bring it back down and use it again. And so one of the most fascinating things I ever saw was a rocket going to space. Now, the Earth is spinning 60,000 miles an hour. All right, so when you shoot up a rocket, you've moved away pretty fast. That rocket goes up into space, ejects the rocket fuel part of it, and it came down and landed on a 60 by 60 space. That's phenomenal. NASA would have never done that. So when you privatize it, they're looking at, hey, we got to get the most for our buck, for the dollar we're spending, and you're seeing that both with SpaceX and I know I'm long-winded, but Boeing. That's the answer to that one.
So just to reiterate, that first question about Mars was asked by Larry. This last question we just answered was asked by Monica. And I have another question from Grace. I think there are a couple of directions you could take the question, but the general question is, how much does it take to become an astronaut? And I think you could answer that either in terms of like money or education or experience. So generally, what do you think what kind of work and resources do you think it would take for somebody to become an astronaut?
Okay, so if I was in 8th grade and I want to become an astronaut, or 9th grade or 10th grade or college, you'd have to stay in STEM. I've said it, you got to say it again and again. You got to stay in the sciences, technology, and math, right? You got to stay in those fields. You got to be, if you're an engineer, that's great. If you're aeronautical engineer, wow, another big plus, right? If you flew jets, but to get in any of those fields, you have to stay in the STEM courses. So if I was to tell anybody, you want to be an astronaut, stay there, go get a degree from some university, but stay in engineering or related fields. And I'm telling you that the astronaut demand is going to be growing. And so every time I see anybody in the 8th, 9th, 10th grade, I say, guys, or even 5th grade, stay in STEM. And when you get out of college, if you have an engineering degree, go look at NASA. You don't have to work for them, but go look at them. I never looked at them when I was in college. Of course, I didn't stay in STEM either. But that's what you got to do. That's just kind of the bottom line.
Okay, that's very helpful. Does anybody have any other questions here at the end? Give it a moment just to see if anybody pops up another question.
Is there any kids out there going to think about being an astronaut? I'd like to ask that question. Anybody interested? Would they be able to say?
I can at least send it out in the chat.
I hope I hit one.
Yes, we have all capitals, yes. So somebody is very, very excited. A couple, maybe. So like we have a couple people who are certainly, they're interested. And one person.
Just keep it in mind. That's all. As you're going through school, right? Just keep it in mind. Go look up NASA. They got 90,000 people. They're all over the United States. They're just, they got different locations, different things to do. But just keep it in mind before you graduate. Go look at them. It'd be fascinating to be an astronaut. Oh my gosh.
At least one person that says that they wish they were a kid again.
Yeah, me too.
Another shot at being an astronaut.
Yeah, if I was in high school, I would be doing that, but those days are gone.
But it definitely seems like it's a very exciting and good time for people who are younger and interested in space and NASA to become, to take steps towards potentially, moving into aeronautics like that.
Sure. It
seems the demand could be growing.
It will be. Not if. It will.
Oh.
Definitely. It'd be a fascinating field. You wouldn't be bored.
Grew up on space. Dad was a flight surgeon for the Air Force and assigned to the medical recovery team when the shuttle was forced to land at Edwards AFB. So that is, again, from Monica.
All right.
So very exciting.
Yeah.
I hope everybody enjoyed this presentation and got to learn some interesting things about space and modern space exploration. It seems like there's more opportunities every day. But thank you all for coming out. We really appreciate it. Now, Jerry, we got at least somebody who was unfortunately joined a little later, did ask if the slides would be available. If you'd be interested, would you mind sending those potentially to us? Maybe we could
sure.
distribute those out to the participants who watch this evening. So if you signed up, which means you came in tonight, even if you showed up a little later, we might be able to send those out for you to view. Other than that, I think we're about done. If there's anything you wanted to, I
want to say one thing.
Go ahead.
Guys, next year, the Webb Telescope, okay? You got to remember that. Spider-Man shoots out webs.
And that's W-E-B-B, yes? Yes,
W-E-B-B. It's going to be, I'm telling you, it's going to change the way we look at the universe. And it's the biggest thing that I've been in astronomy 25 years. I don't know, a long time. And I'm so excited about that thing that I love talking about it because it's going to change. I just hope it works, because when it goes out 1,000,000 miles, we're not going to be able to get to it. And if you go to a video of it, this thing unfolds in space. The mirror, every one of those little squares unfold. So you got to go look at it. It's because when it launches, the mirror is not out, and when it gets into space, it's like a truck caravan. And it opens up, and then the sun shields pop out, and it builds on top. There's 4 of them. They builds up, and then the mirror pops up, and then it starts unfolding. There's a lot of things. There are a lot of moving parts, and it's got to be right, because someone will lose their job. So Webb Telescope, that to me is key. Oh, and something that just happened 2 days ago, I forgot to mention this. They found some toxic material in the atmosphere of Venus, which is a planet about our size. It's next to us, right? So Mars is on one side, Venus is on the other side. So if you're interested in learning a little bit about what that meant, I didn't do slides on it because I only had so much time, but that's like the last 3 days.
Yeah, that was very recent.
Yeah, very recent. And so there's some gaseous material in the atmosphere that could be caused by decaying bacteria, which is life on Venus. Now, I'll just leave it there. It's interesting, but I get 2 astronomy magazines every month, and I'll read something next month, and then the next month is completely different. So, but exciting. So that's the most recent I have. So thanks again for having me.
You are welcome. We're very happy to have you. Thanks for giving this talk.
All right.
Anybody who is here, we hope you enjoyed the presentation. Any of you people interested in NASA or the space exploration, we hope you found this really inspiring. Keep at it. And we will head out. I will just briefly remind everyone, we do have another presentation this Saturday. You can feel free to look up on our event calendar or Zoom and get yourself registered for that. But for now, I'll just say thank you very much for joining us, Jerry.
One more thing.
Oh, yes.
The Oakland Astronomy Club, if you're interested in looking into the sky, contact them, because they're right into Addison Oaks, and it's a big telescope. So
that's the Oakland Astronomy Club.
Yep.
Feel free to look them up. They are local. And with that, I think we will go ahead and call it a night. Thank you all for coming out.
Thank you.
Good night, everyone.